Hey, Vlad here from devinside.com. Welcome to another video. We're still not done talking about the reader channel, and I would like to remind you that it is actually optional. If you don't like it, you don't have to use it. However, if you want your code to be idiomatic zio code, you should keep learning about it. Let's get right to it. All right, so this is where we left off, and we saw in the, by the end of the previous video that if we keep insisting on using the reader monad, right, the reader channel for the program, right, like this, if I comment all of this out, if I'm going to try to provide over here the business logic dot make, that we're going to have a compilation error over here that is going to say that it found Google was a business logic, but it required a console, which is not what I wanted to see. Hold on, I forgot something. Yeah, so these guys need to be in business logic like this. All right, let's see. Yeah, that looks much better. Okay, so it says required business logic and console. So somehow we need to provide both. In fact, hold on, let me actually see if we can make it a bit more evident. What I want to have is I want to go to using our zio first, and I want to kind of like mix and match over here a little bit. So if I do this, okay, but I still use this program over here, right? And I do provide business logic, something like this. Let's see how this looks like, because I don't want to provide over there, right? Like this. So this should still be, okay, so this should still be called make program, I guess. Okay, so this is make program, right? It wants the business logic. So over here, we're providing the business logic. I believe actually now the error message is going to be, is going to look a little bit more pretty. And let's see. Yeah, so this is a bit more pretty, right? So it says I found, okay, and see like this number two. Hold on, I think we can fix this as well. Here, yeah, let's do BL, and let's do BL over here. Okay. Yeah, perfect. So this is a perfect error message. This is what I wanted to have before, right? So it says it found a business logic, but it actually wanted a business logic and a console. Okay. So now if we go back to our zio, I would actually like to see exactly the same message, right? I would not like it to just work like this, because in our case, console is hard coded, right? So the zio environment does not need to provide it. Okay. So as a first step, we're just simply going to go and we're going to do the same pattern as we did for the business logic, right? So we just surround it with an object. Okay. So let's go to console, which is over here. So this is going to be the object console. Okay. And over here, we're going to say new, and it's going to be new trade console. Okay. So we're going to have a trade like somewhere over here, trade console like this. Okay. It's going to have like these two methods like this one, and we actually need to start annotating types over here, right? So it's going to be zio any nothing unit. By the way, in the real zio, this is actually an IO exception, but it doesn't matter much for us. So put string line, get string line. Okay, never use vals in your traits, right? So this needs to be a def get string line, and this is going to be zio any nothing, and it's going to produce a string. Okay, and so now what we need to do is we need to wrap it into an object console. Right, this is like sort of like the pattern. By the way, it's not a complete pattern. We're gonna arrive at the complete pattern at some point. Okay, so now we need to go over here, and this is going to be lazy val make of console equals this whole thing, right, like this. And we're also gonna have live lazy val live, which is gonna be a zio of any nothing console. Like this is the one that that we still need to finish the conversation about this, right? We did this a couple of videos ago, and we didn't arrive at layers, but we will at some point. Okay, so we have live, we have make, and now we need to have two delegation methods to these guys, right? And let's make sure that they are at the appropriate scope. So they should be yeah, they should be at the same level as this object. And sort of like the whole point of them is that instead of any, they're gonna require the console. Okay, so the implementation is going to be simple. In fact, maybe I can just do this, and I can do zio.access m underscore dot, and we're gonna grab this, gonna go here, okay, like this, and put string line like this. Okay, so equal sign. There we go. Okay, so this thing compiles. Okay, so it's now an object, same as the business logic inside. There's the actual trait. There's an object. It has a life. It has the make, and it has the delegation methods. Okay, so now if we go over here, if we scroll down, what is it going to say? Now we see exactly the same message as was Zio. It just said the compiler blessed Zio with more colors. Let's actually go and switch to it real quick. Import Zio. Yeah, right, because the namespaces are different, but essentially it's exactly the same error message. Okay, let's go back to ours. By the way, I also forgot to actually go and change this, right? Because now this is going to be console, right? Remember, the actual Zio environment is actually a compound object of console, clock, environment, and blocking, and the random generator, I guess. Okay, so it's going to be clock, and so now we need to provide it over here, right? So we can either do .provide, right, console.console.live, make, right, or we can simply run it with this thing, right? So we can simply run it. It's a little bit less code, right? So we can run it with no provide like this. Okay, so we'll simply run it, which means that if we were to go back to the original program, this one, the make program like this, right? And this is going to be not provide BL, but just like this. And this is going to be BL like this. It's going to work both in our Zio and in the real Zio, right? Because now both environments know how to provide the console, right? However, if we go back to this one, right, we now somehow need to provide both the business logic and the console, right? Because over here, it says like, hey, somehow we need both. We need the business logic and the console. So somehow we need to go over here and do something like console.console.live, right? But we obviously cannot just compound like random types like this together, right? We cannot just combine business logic and console. Now, there are several solutions to this. The most straightforward one is the cake pattern. So let's go and implement it first. It's not the real solution, but Zio actually comes with a thing called Has that allows you to build sort of like an ad hoc cake pattern, right? So you can build a cake pattern without defining it first. It's actually kind of cool. Uses a bit of reflection. We're going to implement it ourselves in a second. But for now, let's actually go and just do Has console. And it's going to have the console, which is going to be the Zio playground.console.console. Okay, now it's going to have trait has business logic. It's going to have BL, right? Forgot the def. Got the def, right? So it's going to have def business logic or BL. Zio playground dot business logic dot business logic. Okay, like this. So now we can go over here and we're going to provide, right? We're going to provide a new has console with has business logic. Okay, how we're going to do this? Well, we're going to override lazy val console with Zio playground.console.console.make, and we're going to override lazy val business logic is going to be BL that comes from here, right? And now we managed to provide both. And now we go over here and use our old trick and we rip out the environment, zio.environment, right? We're going to say has console and has business logic, right? Then we can do, well, pretty much everywhere where we use the errors, right? env.console. I forgot the last one. env.console. Okay, and now this way it's going to work. Now we could also like add these delegation methods to our cake pattern, but we don't need to because we're going to get rid of it in a second anyway. All right, so as already mentioned, Zio has this thing called has, and it allows you to build this cake pattern sort of like ad hoc. And the way this works is that it's just a tiny it's just a tiny class. It has a way to put things into a has, to get things out of a has, and to compose two hases together. Okay, so this basically means that we're not going to need this. Before we're going to implement it, we're actually going to use the one from Zio. Okay, so I'm just going to remove this. I'm going to remove that. And over here, I'm simply going to say has business logic, right? So it's inside of Zio, right? Zio has business logic. And we can do ++ zio.has, and we're going to give it a console, right? console.console.make. Now over here, this is going to be zio.has console and zio.has business logic, and we need to be a bit more explicit because they're now inside of these objects as console dot. Okay, and the way you get things out is by essentially trading names for values. Like with implicits, you trade names for types. Over here, you trade names for values. Okay, so over here, instead of saying env.console, we're going to say get and then the type of the console. Okay, so everywhere we say .console, we're going to say .get, and then we're going to give it console.console. Okay, and over here, everywhere where we say .businessLogic, we're going to say .get businessLogic dot businessLogic. Right now, obviously, we're going to make it prettier at some point, but by now this should be fine. What is happening over here? Oh yeah, okay, over here. I'm not sure why the error is drawn like over there. It should have been over there. Okay, so as you can see, it works now. Again, it became uglier, but we're gonna make it pretty in just a second, more like a minute. By the way, this particular video, it actually might end up being kind of long, so I might split this one into two. By the way, this has thing also has, you know, the alphanumeric name, which is union, which we need to, yeah, thank you. There we go, it's union. And Metals did not notice that the Scala compiler fixed it already. There we go. Okay, so I actually prefer this one. And when we're going to implement ours, we're actually not gonna need the backquotes. All right, so now let's go and build our version of Has. It's going to be very, very small, and it's actually inspired by a video that Kit Lanton did a couple of, well, I guess it's probably a month from now. And by the way, every time I mention some videos, I'm using a YouTube's feature called info cards, right? So you have to explicitly enable it, otherwise you're not gonna see this pop up over here or over there. All right, so let's go over here and build it. So Has is going to be simply a wrapper around a map that goes from any, I'm sorry, from string, which is going to be the name of the class, to any, which is going to be the values of this class. We're going to use the Scala's reflection to get out the name of the class, and we're going to use some very fancy types and even casts to actually get out our types properly. One cool thing about it is that it is a map, right? So you can add things with the same key, and the previous value is going to be overwritten that is associated with this key. This means that you can have an already assembled dependency graph, you know, the one that has all the dependencies already provided, and you can simply use it in your task and simply override some of the dependencies. It's very convenient, but to be honest, it's only useful if you're writing something like acceptance or integration tests, right? Because when you're writing just unit tests, there's nothing, you know, it doesn't save you much code. All right, so first we're going to go to the very top of the file, and we're actually going to, oh my God, what is this? What? Oh, that's why it, like, Metals imported some stuff for me, and that's why we had this new. I really want to get rid of it. Where are we using new? Yeah, this one. Yeah, see, so now, like, I knew we didn't need the new keyword. Go up. Okay, so what we want to have over here is we want to import scala.reflect class tag. Okay, we're simply going to use it to get the names of our classes out. Okay. So it's going to be a final class, Has, and it is invariant, which might become relevant a couple of videos from now. It's going to have a private constructor, and inside of it, it's going to have a private val, which is going to be the map, right? As already mentioned, from strings, which are the names of the classes, and to any. Okay, so now we're going to have an object has like this, and it's going to have a def apply, right? We're going to give it some a, right? We're going to give it some a, okay? And we're going to use a tag, class tag for a, and we're going to construct a has a. Okay, how are we going to do this? Well, we're going to use new has like this. We're going to create a map. Okay, we're going to rip out the class name from the tag.toString, and a like this. Okay, so now we can already create hases. The next thing is going to be way more complicated. So over here, we're going to have an extension. We're going to have an extension for some a, right? And this particular a is going to be a has. Okay, in the Scala 3, we need to use a question mark over here instead of the underscore, right? This is going to be a has question mark. Okay, so this is going to be an extension for some sort of has. Okay, and it's going to have a function called plus plus that is going to take a b, which is also going to be some sort of has, right? So we're going to have the b. Okay, and it will produce a and b, right? In Scala 2, this would be a with b, but over here we're going to do like a and b. Okay, how we're going to do this? Well, we're going to create a new has. We're going to get the map from the first one. We're going to add it to the map from the second one. Okay, and that should be it, but the Scala compiler is not able to actually infer this type. Okay, it actually infers, it says like, I found has of nothing, but I required a and b. Okay, so we need to help it out a little bit. We need to say as instance of. It's going to be fine. It's completely safe. Okay, as instance of A and B. By the way, I would like to take a tiny detour and introduce an annotation to you that is weird as hell. It's the annotation that was introduced in Scala 3 called target name, right? So you can do this, union. Okay, but you're actually not going to be allowed to call it. At least I didn't manage to call it. We will actually try to call it. So what this thing does is it basically says like, hey, plus plus is just an alias for union, and if you're using this library from say Java, then you would be able to use the name union. But if you use it from Scala, you actually cannot use this name. And in fact, if you try to go and overload it, right? So we go over here, right, and we're going to do union. It's going to say that it's already generated, but I didn't manage to use it, right? So I was like, okay, well, if it's generated, then I can remove it and I can use it, but I can't use it from Scala. This is so weird. Okay, so in fact, I'm actually going to remove it, and we're going to have union, okay, like this, and we're going to mark it as infix, right? Because we want to be, we don't need to do like these things, okay, right? And plus plus is simply going to do union of B. And I guess it's now it can become an inline def. All right, one thing left is how do we get things out of our has? And it's going to be a def over here called a get, right? And it's going to get an s. And we use as for service. This is the part of this whole pattern you're going to see later why. Okay, so what we're going to do is we're going to use a tag, class tag of s. Okay, and now we're also going to need a view from A to has s. Okay, and this is how we're going to produce an s. Okay, like this. Cool. So then we're going to have an equal sign over here. We're going to go over here, and I forgot the column, which is why the syntax highlighting is broken. Okay, I'm going to go over here. So I'm going to take our A, right? This is the extension for A. We got a map. We're going to use tag to string as a key, right? And obviously this is not going to be the type that we need. So we're going to simply say as instance of s, right? And there we go. By the way, if you don't like this, you can use this. Okay, just be aware that it has a different precedence. And in fact, we're going to run into a couple of issues with this a bit later. But I'm going to go back to using this. And by the way, no matter which one you use, there's actually a big difference between in the order of these parameters. I'm going to leave it like this, and at some point in the video we're going to run into an issue with type inference. This cost me like half an hour to figure this out. Also, one other thing that I'm going to show you later, in Scala 3, when you use the using parameter list, you don't need to use the names if you don't use them. Over here we use the tag, but we don't use the view. However, I cannot leave name out in the same parameter list. However, in Scala 3, I can actually separate the parameter list. So I can say like this is going to be the first one, this is going to be the second one. And in the second one, it's still going to be a using parameter list, but I don't need to specify the name, right? So we're not specifying view, okay? Like this. In fact, let me actually revert to some. I'm simply going to say view like this, okay? In Scala 2, we actually used to have this thing that was deprecated, right? So this would have been a view bound, which wouldn't work in this case anyway, but still cool. So now we can actually go back and remove the zio dot so that we can start using our own zio. Well, not this one, right? So over here, right? I believe this is the only place, right? Over here, we're creating two of them, we're uniting them, and we're getting them out. And yeah, so it works exactly the same. It's just that ours is more awesome because we don't need the backticks. By the way, the real implementation is a bit more advanced, but this is good enough for us. And if you want the details, watch Kit Lanting's video. All right, now we should go and make it pretty. But before we actually do that, I would like to point out an interesting thing, that the Zio environment actually could provide the console for us, right? So we're providing like a production grade version of the console over here. Zio actually could do this for us. In fact, it does this for us, right? Remember, in the environment, it actually does this. So we're going to take a tiny detour and introduce a couple of combinators that will allow us to provide like a partial layer and also provide like a custom layer so that the Zio environment can provide like everything else that is left from the environment. Okay, the first step is going to say that over here we need a has, right? Has, and obviously we need to mention it over here. right? So this is going to be like the first step. It doesn't change anything over there, but it's going to help us out a bit later. What we want to have is over here, instead of providing both of them, I want to be able to provide like only the business logic, and I want the environment to provide the rest. But we can't, right? Because this program, it says that it wants both. It wants the Has console and it wants the Has business logic. Okay. So what we're going to do is we're going to have another combinator, right? We're going to call it provideSome, because this is how it's called in Zio, and it is going to want a function, right? A function that will basically say, okay, so assuming that I have the rest of the environment, which in our case is going to be Has of a Zio environment, right? Then please tell me, how would you construct the entire environment? Well, I'm going to take the rest and I'm going to simply unite it with the Has. Okay. Now it says like, hey, you don't have the provideSome. So what we're going to do is we're going to go and we're going to define this provideSome operator. And usually you would write it in such a way that you would specify what is missing, right? You would say, hey, the only thing that is left is Zio environment, right? And then over here, you wouldn't need to specify this type over here. It's going to be simply, let me remove this comment like this. Okay, so it's basically going to be like whatever comes in, just unite it with the business logic, and then we're good. Okay, this is how it should look like. Okay, so let's go and create it. So we're gonna put it right. So it has to be inside of Zio. So let's put it above here, between access and between the environment. Okay. So it's going to look like this. We're simply going to say provideSome, right? Then this is going to be the rest, right? And this is going to be the function from the rest, to R. Okay, it's going to produce a Zio of R0 E A, and it's going to be a little bit complicated, so we're going to spell it out. This is going to be a full comprehension that in the end is going to yield an A, right? Because we need to produce a Zio of A. Okay, so the first step is going to be, to get the R0, right? We're going to get it from zio.environment R0. How convenient, that environment's like right there. Okay, so now we need to get the R out, right? R0. Okay, so now we have the R. We need to produce an A. We're inside of the Zio that wants the R, that knows how to produce the A. So we're simply going to like iterate it once because we're inside of the full comprehension, and then we're going to return the A. Okay, so we're simply going to provide the R, right? We're inside of the Zio that wants the R, so we're providing the R, and therefore we can rip out the A. We're returning the A, therefore the whole thing returns a Zio of A in the end. Okay, like this. So this is provideSome. And provideSome calls provide that. Where did it go? Where did our provide go? Oh, why did I put in the companion option? Man. Let's go over here. Over here. Perfect location. Like this. Okay, provideSome, provide. Now let's make it a little bit prettier. So we can take this and just inject it over here. Like this. We probably don't even need to do R0. Yeah. Now we have already seen this trick before, where we're doing like Zio environment and blah, 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 right? So this is the XSM that we have before, okay? So instead of like these two lines, we could have just written zio.XSM, okay? So it's going to take the R0, right? And we're going to provide the F of R0 like this, right? And it's going to give us the A like this, okay? So let's see if it works. We might need to specify the type. Yeah, so we might need to specify the type. Okay, so now we're inside of a full comprehension that constructs a Zio, rips the A out, and returns the A out. So it turns out that we don't need the full comprehension, right? It's just this, and it's just that. Okay, and now I believe that we don't even need to specify the type, and we might even be able to use an underscore, but I don't think we will be able to. Yeah, that is too much of the goodness, right? So this is why I didn't want to write this thing in the beginning, because like we're moving in this territory where the combinators are so powerful that it's actually kind of hard to read them, even for me. So as you can see, everything works right now. Right, there we go. Now, it is very common to provide everything except for the things that the Zio environment would provide, because in a real Zio application, you would actually, you would not define your own console. You would use the one from Zio, and the same thing with a clock and with a random generator and stuff. Now, Zio has this concept of Z layers, and Z layers, they solve like several problems. And one of the problems is basically hiding this whole complexity that comes from has, like this whole stuff of has, right? So it hides all of this stuff. And so all the combinators that we would have wanted to introduce, as soon as they deal with has, Zio puts them into Z layers. We don't have Z layers yet, and we will arrive at Z layers in the next video, actually. And then we're going to create a combinator right now that actually doesn't belong here. It doesn't exist in Zio, but it does exist in Z layers. Okay, it's going to be called provide custom. It doesn't exist, right? And Z layers, by the way, they're simply like sort of like wrappers around Zio. So whereas you have Zio succeed, you would do Z layer succeed. If you have like Zio dot from function, you would have Z layer from service, and we're gonna learn about services soon. And so you have like all of them, right? And because of layers, we're gonna end up having functions over here that are not just gonna be called provide. They're also gonna be called provide layer or provideSome layer. And there's gonna be one that is gonna be called provideCustomLayer. And it's basically gonna be a provideSome where our 0 is already known to be the Zio environment. So we're gonna introduce it over here, even though it doesn't exist in Zio, even though we didn't arrive at the layers yet. The signature is going to look a little bit complicated, but it's still going to fit into one line, I believe. Okay, so we're going to call it provideCustomLayer. Again, it doesn't exist in Zio. In Zio, it exists on it does exist in Zio, but it will return a layer instead of Zio. We're going to provide some R1. Okay, which is why it needs to come over here. In fact, you know what? Actually, we're gonna do this. I'm gonna have like a tiny legend because otherwise it's gonna be very, very complicated. So our R, we're inside of Zio, right? So our R has Zio environment and has business logic. Okay, so our R1 is going to be the thing that we're providing, right? So R1 has of business logic. Okay, so let's move it over here. Okay, like this for now. Okay, so now we're going to continue writing this, and we're going to say we're going to need an evidence, right? It's basically like a view that something that has a Zio environment and R1, which has business logic, right? So basically has Zio environment and has business logic, that it can be mapped to R, which has Zio environment and has business logic. Okay, so over here we can say has Zio environment and R1 has Zio environment and has business logic. Okay, so let's put this guy over here and over here, something like this, maybe like that. And this is the R1 because it's now over there, like this, a teeny tiny table like this, right? So this means that we can go from this to this, right? Because going from this to this is exactly the same thing. Okay, so now assuming that we can do this, then we're going to have a Zio that has a Zio environment, right? So before was provideSome, it was some random R0. For this one, it has to be fixed for Zio environment. EA is going to be, well, it's going to be provideSome. We're going to specify that we're talking about the Zio environment, right? So now what we're going to do is we're going to have the function, right? The same thing as we're doing over here, right? So this is the function union has BL. In fact, we can copy paste it, put it over here. It just that this has BL over here is going to be R1, okay? And we need to help the compiler out a little bit. Okay, so we're going to do dot union. We're going to do R1, and we're going to have as instance of R. Oh yeah, actually I wrote this down like that R1 has business logic, but I actually forgot to tell the compiler that this should be some sort of has like this. All right, there we go. Provide custom layer. So now we can actually go to main and we can simply provide custom has BL. Okay, so provide custom is not a member of Zio Playground. What? Why? Oh, because I call it provide custom layer. Yeah, provide custom layer, right? But it's not a layer, it's just it has BL. Okay, and now the Zio environment at the very bottom over here provides the rest, which is the console currently. In fact, we can actually go a little bit overboard and sort of try to like to hide this has, right? So Zio doesn't have this, but we could do like provide custom, and we're just going to give it BL, and it's going to construct a has for us. So we're just going to go and add it real quick. I know it's a very long tangent. Right, so let's throw this out. This is going to look very similar, right? So it's going to be called provide custom. right? So now this R1 is going to need a class tag, right? Still going to have R1 over here. Now we're going to have using the zio environment and has R1. Actually, not the zio environment, the has zio environment and has R1 and R. And maybe actually this is the location where I ran into this this issue. So we're going to have zio has zio environment EA, right? And we're simply going to call provide custom layer, and we're going to wrap this thing into a has R1 like this. Okay, and now everything compiles. Let me actually check, because I think like this is exactly where I ran into the issue. Let's see. And yeah, this is exactly where I ran into this issue, right? Because now it says that that it cannot prove stuff, and it's because of the precedence, right? So we simply need to wrap it like this, and then everything is fine. Okay, so this is not the reason why I prefer just to use the regular function, but still, it's not gonna fit. Yeah, now it fits. Okay, great. So we have provide custom, doesn't exist in Zio. We have provide custom layer that exists in Zio, but it actually returns a layer and not the regular Zio. And these guys are still fine. Okay, they actually exist in Zio, and they pretty much look exactly the same. All right, now this was a huge tangent. We still have a huge problem over here that we need to get rid of this whole has thing. Okay, and the idea is basically if you keep insisting on using the reader channel, then you'll probably want to use something like access m. So why not build has into access m? Also, let's create type aliases so that we don't have to spell out this whole has thing all the time. And this is what we're going to do next. Okay, so what we're going to do is we're going to start by going to our Zio environment, and we're simply going to say that this is going to be already a has, right? If you insist on the reader channel, you're going to want to use has all over the place. Okay, so now we can go over here and we can say that basically everywhere where we say has Zio environment, we're simply going to say z-env. Okay, because now it's a has. What we're going to do now is we're going to go to console over here. I'm actually going to jump in there first. Okay, we're going to rename this to service, and this is also why we use the letter S over here when we get the service out of the has. Okay, this is sort of like the whole pattern of Zio. Okay, so we're going to take console. Metals is going to help us to rename this to service. Okay, save all. So now that the console name is up for grabs, we can actually go over here and create a tiny alias for console, and it's going to be simply a has service, right? Which is going to be has like the the console service, which is over there. Okay, I'm sorry, over here. And by the way, it's also a convention to move this trait inside of this object. So let's also do this like this. Okay, so this is how it looks like. Okay, so you have an object console. Inside of it, you have a type alias that redirects to has. Inside of it, you have an object service that Metals actually renamed for us. So we should actually go back to console. Okay, so you have type console, you have an object console. Inside of it, you have the service. And let's see if we actually need to fix something over here. Yes, over here we would need to say console.service, and same thing over here, console.service. Okay, so we're going to fix this later as well, so that that we're actually going to use a console as well, right? So accessam is going to do like .get, but we're going to get to this in just a second. Let's go and fix the errors over here first. Let's see, Metals, what happened to you? Can I press F8? Yeah, there we go. There's probably some issue at the bottom first. Console. And what else do we have here? As console.service. And what else do we have here? Yeah, make return to service. So we're wrapping it into a has. It should be fine. We are running it with has console dot service like this. There we go. Okay, so now we can go to main, go fix this stuff. Okay, so this is going to be console.service. Well, actually, we already have the alias, right? So we can simply say that this is the console, right? Console.console. This was like sort of like the whole point. And over here we can do console.service. Okay, so this is again like this is the first step, and the first step is like always like make it uglier, So now we can go and we can change the delegates, right? So in the console. Over here, like these guys that do an access m, they should just be able to access the has, right? Because they will be able to just get get the service out of the has and the call this function, right? And this is the location that I meant that we're actually running into the type inference issue that actually cost me half an hour to troubleshoot. So if we go and switch these guys, right? So if we have the view, first, right, then it's going to compile. This is so unfair. And yeah, we're actually not using the name. So yeah, I think I'm going to remove it like this. And I'm going to use a tag, using tag, right? Even if it's curried, right? Usually when it's curried, the type inference is actually a bit better. But if you swap them, no. This is probably a type inference bug in Scala 3 or type inference limitation. In fact, we're going to run into a couple of type inference limitations and or bugs. I actually have no idea. Right. So in the end, we're going to assemble like this big, gigantic layer of services, and we're going to look at the type that is inferred, and it's going to be the correct type, but it's not going to show us that it's going to be the correct type, right? So everything is going to compile, like everything is going to be like inferred, but what is shown is incorrect. And it might be metals, but I don't think that it's metals, because metals like takes the stuff that the compiler gives. In fact, this is a perfect place for a comment, which is why my comments are red. So you see them right away. Do not change the order of the parameter list. The current order is more type inference friendly. And again, if we swap them, right, it's just a type inference issues, right? So at the top over here, we would say get the do we have the access to the service? No, we need to say get console.service, right? Get console.service, and it will work, right? So it's just a type inference issue, right? So let's go back. There we go. Okay, so now we don't need to specify the types. All right, so now we need to go and do the same thing for the business logic. Or actually, we forgot to actually use it. So now over here, we should be able to just say, right, so everywhere we say console, we should be able to say console. Yeah. Right. So now we need to do the same thing for the business logic so that we can go back to this and we don't need to we don't need to get the stuff from the environment. So we already have an object, we already have a trait. So now we're going to go over here. We're going to say business logic is going to be a has business logic dot service, right? So we're going to take this thing, move it down, right? Oops. We're going to call it service like this. This is going to be Google, nothing service. This part is also going to be changed, right? So this is going to become a has in the upcoming video. I believe in the upcoming video. I don't think that we're going to do this in this one. All right, so let's see. We have the life, we have the make. It looks all good. Over here, we need to do get, and therefore over here, this is still fine. Yeah, I believe this is actually at least for this part. Okay, so this one actually creates the service. Like this. Yeah, so this part is done. We just need to fix a couple of types over here. So I guess for now, this is going to be service. Like this. What is left? Provide custom BL. Yeah, so this needs to be service. And this needs to be has dot service, or actually it can already be, we already have the alias, right? Like this. And now we can go and just do over here business logic, and the same thing over here, business logic, and now we don't even need to get the environment out, right? And the inferred type is business logic and console, but actually these are type aliases, right? So this is actually has business logic and has console, right? So if we actually go back to provideSome instead of provide over here, right? Over here, no, I'm sorry, over here, right? So over here, if we go back to provideSome, zio environment, right? And we're going to grab this thing and we're going to do union has BL like this, then with this code, we could even go back to the real zio, and now it's going to work exactly the same, right? So the inferred type is going to be zio of business logic and console, and as already mentioned, the real console in zio actually produces the IO exception as in the error channel, and not nothing, but it's not a big deal. All right, so let's remove it so that I don't forget to remove it. And yeah, there we go. So we're almost done improving everything. Has still leaks out a little bit, so we're gonna remove it in the next video, and we're going to introduce the layers for this, right? Because as of right now, the assembly of the dependency graph over here looks weird. Like sometimes you need a has, sometimes you don't. It's kind of weird. All right, so I hope that you're not too confused. We're almost done talking about the reader channel. We're gonna have one, maybe two more videos about it. For now, as always, it's Vlad from devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on GitHub sponsors or Patreon, and thus watch my videos weeks and sometimes even months before everyone else, including this series. And most importantly, take care.